So I had a lot of questions about partial fraction decompositions. And so what I wanted to do is I wanted to make a video. This first video is going to be about a little bit about like factoring and some ways to go about doing some factoring or a particular method for factoring. The bottoms of your partial fraction decompositions. And then the second part is going to be about an easy way to find your A, B, and C if you have linear terms, right? Because some of the things that I've been seeing is nothing wrong with it, right? Absolutely correct, but maybe kind of a long way around. Like you don't actually have to work that hard in order to do these partial fraction decompositions. So what we're going to do is we're going to look at this problem. We're going to look at 19x squared plus 24x plus 8. And this is going to be divided by 21x cubed plus 26x squared plus 8x. And we're looking for the integral of that dx. Okay, so we want to know what is the integral of that. And so you look at that and you're like, okay, cool, I get it. Like what I can do is I can use partial fraction decomposition. We notice that the bottom actually has a higher degree than the top, and so consequently we don't have to do any kind of like synthetic division. All we need to do is we really need to factor the bottom. So the first thing that I'm going to do is I'm going to just notice I can pull out an x. So I've got 19x squared plus 24x plus 8 divided by x times 21x squared plus 26x plus 8. Okay? And then my dx. All right? And so now I need to factor this. And it doesn't look immediately apparent like how is that going to be factorable. I'm not sure. I'm not exactly sure as to how that's going to be factorable. But so here's what I'm going to do. What I'm going to do is this. I'm actually going to take 21x squared plus 26x plus 8. Okay? And even though I'm not quite sure how it is that I'm going to get 26 from that, what I'm going to do is I'm actually going to use the quadratic formula. Right? So I'm going to have x, this is the root of my equation, it's going to end up being negative 26 plus or minus the square root of, in this case, it'll be 26 squared minus 4 times 21 times 8, all divided by 2 times 21. And so my first root, x, is going to equal, this will be negative 26, and it turns out it's plus or minus the square root of 4. So when you do your calculation, you'll get that, divided by 42. And then what I can do now is I can rewrite this as x equals negative 26 plus or minus the square root, negative 26 minus 2 over 42. And x is going to equal negative 26 plus 2 over 42. So that means then that x here is going to equal, this is going to be negative 28 over 42, and that equals negative 4 over 7. And this x is going to equal negative 24 over 42. Oh, excuse me, this is not negative 4 over 7, this is negative 2 over 3. My apologies. And this is going to equal negative 4 over 7. And so those are our two roots. So now let's rewrite these roots, okay? What we're going to need is, what we'll know is that this function here, okay, we're going to have 21x squared, or excuse me, 21x cubed, right, plus 26x plus 8, okay, is going to then equal, or plus 8x, 21 plus 26x squared plus 8x, excuse me, is then going to equal, it'll have some a, my a value, times x, right, x minus, times x minus 2/3, times, or x plus 2/3 times x plus 4/7. And that's just adding in those linear terms for my factors, right? We've got the x plus 2/3 and the x plus 4/7. And that a has to be 21. It's got to be 21. So this is actually going to end up equaling 21 times x plus 2/3 times x plus 4/7. And what I'm going to do is I'm going to, so that I can get some really neat and tidy linear terms, I'm actually going to multiply this first factor by the 3 and the second factor by a 7. Okay? And so what I get then is this is going to end up equaling x times, and this will be 3x plus 2, and this will be then 7x plus 4. And that is my factorization. All right, so basically what we've done is we went out, we found our roots, we rewrote our equation in terms of those linear terms with the a, right, which in this case is 21 at the front. And then I just multiplied in the factors of 21, right, that will eliminate my fractions, right? Because who wants to work with fractions? I don't really want to work with fractions. I'm going to have to do a little bit of work with fractions, but I don't want to do it right now, okay? And so that actually gives me my my factorization. So what I get now is I've got 19x squared plus 24x plus 8 over x times 3x plus 2 times 7x plus 4. So just in case you're having any problems with like doing the factorization, you can do that. Now here's the thing. Interesting little note is that if for some reason it doesn't factor, you find that you have complex roots, then you know that it's not a factorable polynomial, and you now have a nonlinear term, you have a quadratic term. And we just use that. So we'll take this term right now, the 19x squared plus 24x plus 8, and that's going to equal then a over x plus b over 3x plus 2 plus c over 7x plus 4. Okay? And what I'm going to do now is I'm going to do exactly like what we would be doing normally whenever we do any kind of like whenever we're doing partial fractions. I'm going to take a times 3x plus 2 plus b times 3x plus 2 times 7x plus 4 plus b times x times 7x plus 4 plus c x times 3x plus 2. And we know that that's got to equal 19x squared plus 24x plus 8. All right? That is, that's exactly what we've been looking for. What I'm going to do, though, rather than going out and doing a system of equations, what I'm going to do is I'm actually going to pick some select values for x, and I'm then going to just solve for a, b, and c using those select values for x. I'll plug in the value of x, and that'll actually help me to simplify things. In this case, the easiest one to do is actually to select the roots of the polynomial, because it's going to zero out terms. So let me show you what I mean by that. So we get let x equal 0. We'll let x equal 0. So that means then we're going to get a times, and this will be 0 plus 2, so that our a times 2 times 0 plus 4, and that's 4. Okay, so a times 2 times 4. Plus, and this is now b times 0. So it's going to be 0, and then we have c times 0, so it's plus 0 plus 0. Notice we got rid of b and c. Okay? Awesome. And then in addition to that, we'll get 19 times 0 squared plus 24 times 0 plus 8, and so that equals 8. So this means that we get 8a equals 8, and that means that a equals 1. That is step 1. That's for a. Next up, we're going to pick the next root here that we have, and so that's going to end up being negative 2/3. So we'll let x equal negative 2/3, and when we do that, this term is going to zero out. All the 3x plus 2's become zeros. So we're left with 0 plus b times negative 2/3 times 7 times negative 2/3 plus 4 plus 0 equals 19 times negative 2/3 squared plus 24 times negative 2/3 plus 8. This gives me now that 4/9 b equals 4. You can go in and actually do the equating there. There's a little bit of a work with fractions, but it'll be 4/9 b equals 4. So b will then equal 4 times 9 over 4, which equals 9. So that's b equals 9. That's our second term. Okay. Notice how much easier this is than setting up a system of equations and then doing some kind of elimination. All right. Next, we're going to pick let x equal -4/7. That's our last factor. Again, anytime I have the 7x plus 4, that's going to go to 0. So I'm going to get 0 plus now c times -4/7 times 3 times -4/7 plus 2. And that'll equal now 19 times -4/7 squared plus 24 times -4/7 plus 8. And so now we'll do a little calculation. So after a little bit of fraction work, what do we end up with? We end up with -8/49c equals 8. Yep, equals 24/49. And so then c is going to equal 24/49 times 49/-8, which equals then -3. And that is c. I find that this method, right, which only really works, right, this only works with linear terms, with all linear terms, all right, makes things a lot simpler. You can actually do it if you have quadratic terms too. It's just that there's no way to avoid some systems of equations if you have quadratic terms. You're just going to actually have to do some work, but you can also just, plug in those x terms into there and do that same kind of thing, or this same kind of thing, if you're doing that as well. You're going to find it'll take a little bit more work. And what I'll do is I'll do a demonstration of something like that when I go in and do an example of working with a partial fraction decomposition that has a quadratic term. All right? So now that we've done that, now what we've done is we've set everything up. We've done our factoring. Now that our factoring is finished, we've gone in, we've multiplied through by the bottom term inside of our partial fraction decomposition. We've set those numerators equal to each other just like we normally would. And now it's just a matter of picking the roots, picking the real roots to be these values of x, plugging them in, and then that actually will zero out all but one of the terms. Okay? So this actually turns out to be, kind of not too terrible. So what that means is that my partial fraction decomposition is going to end up being 1 over x plus 9 over, okay, and we had 3x plus 2 minus 3 over 7x plus 4. And there is your partial fraction decomposition. Having to explain it takes longer than it actually takes to do it, right? Just be really careful. Make sure that you do your multiplication and your division correctly. And if you do that, it actually can save you a lot of time. Okay. That concludes the lesson.